Now that we've learned the basics of inequality equations, we have to work on inequality logic. The two words and or are going to make a big difference in writing your solution set. One word can make an entire difference on what your solution set means, and here's why. If I say I am in math class and English class, that wouldn't make any sense. That's a false statement because you can't be in two classes at once. But if I say I'm in math class or I'm in English class, that's absolutely possible, so it's a true statement. The way it works is and must meet both conditions, meaning that one thing has to be true and the other part has to be true, making the entire thing true. For an or statement, it means that only one must be true. Mathematically, if we have 3 plus 5 equals 8 and 5 is less than 7 minus 1, this statement is completely true. Because 3 plus 5 is 8 equals 8, which we know works out. 7 minus 1 is 6. 5 is less than 6, which work out. So this statement is true. However, let's say we flipped this sign around and made it 5 is greater than 7 minus 1. 3 plus 5 equals 8 is still true, but 5 is not greater than 6. So this statement is false, making the entire statement false because it hasn't met both conditions. Here for an or statement, we have 10 plus 2 is not equal to 12, or 8 minus 3 is greater than 0. So we know we only have to meet one of the conditions. 10 plus 2 is 12, which does equal 12. So this condition is false. But 8 minus 3 is 5, which is greater than 0. So this part is true. So this entire statement is a true statement because it met at least one condition. Let's work on some examples. What you do when you're dealing with conditional statements is you set up each equation and you do them separately. So x plus 8 equals 3, get rid of the 8 to isolate x. X equals negative 5. Bring down your or sign. Very important. Now you do the next equation. X minus 6 equals 2. Isolate x using the inverse property. X equals 8. So now you know your solution set is x equals negative 5 or x equals 8. Now let's look at some examples of and statements. Here we have x minus 6 equals 1 and x plus 2 equals 9. Again, do each equation separately. So isolate x. X equals 7. Bring down your condition statement, which is and. X plus 2 equals 9. Isolate x. X equals 7. So your solution set would be 7 because it meets both conditions. Here, 2x minus 8 equals 10 and w. And x is greater than 9. 2x minus 8 equals 10. We have to isolate x. 2x equals 18. X equals 9. But 9 is not greater than 9. 9 is equal to 9. It doesn't meet this statement, and because it doesn't meet both conditions, you would have an empty set. Here we have two conditions. X is less than 3 and x is greater than negative 1. So let's put this in on the number line so we can figure out what numbers meet both conditions. This would be for an and statement. Now the right hand's right here. Okay, if x is less than 3, we know we have an open circle and we're moving this way to the left because our value is becoming smaller. Here we have x is greater than negative 1. So again, circle on negative 1 and we're getting larger. So we're going to the right. So here in this area we have red, only one condition is being met. So we don't have to worry about any of the numbers here. Here we only have blue. So any of the numbers here are only meeting one condition. However, the numbers in between from negative 1 to 3 meet both colors or both conditions. So for this statement, x is less than 3 and x is greater than negative 1, what has to be true from this statement? from -1 to 3, not including -1 and 3. So the way we're going to write this is we put our smaller number first, which is -1. X is greater than, see, x is greater than -1, and then x is less than 3. So this whole solution set means that x is in between -1 and 3, but does not equal -1 or 3. That's how you would write your solution set. Now we're going to look at a number line with an OR statement. So again, x is less than -4. It's not equal to, so we're having an open circle, and it's going to the left because it's becoming smaller. Here we have x is greater than 0, not equal to, so we have an open circle, and it's getting bigger. So, what is clear right away? We have no overlapping conditions. Each one is doing its own thing. However, because we have an OR statement, this is okay. So the way we would write this is literally just like that. X is less than -4 or x is greater than 0. Let's look at another example, but this time I'm not going to tell you if it's an AND or OR statement. Here we have x is less than -4, not equal to, so it's an open circle and it's moving towards the left because it's becoming smaller. Here we have x is greater than 0, again open circle, and it's moving to the right because it's becoming bigger. Now, what we notice right off the bat is that there's no overlapping values, which means that there are no two conditions that are being made. So we know this has to be an OR statement, otherwise it would be a false statement if it were an AND statement. Let's look at another example. Here we have x is greater than 0, not equal to, so we're putting an open circle and it's going to the right because it's getting larger. Here we have x is less than or equal to 10. So it's equal to, so we're shading it in, and it's getting smaller because it's less than. So when we look at this, let's ask a couple questions. What is our biggest value? What meets this condition is when it gets 10. Okay, 10 is our greatest value and it can equal 10. So we know our greatest is 10. What about our smallest value, our least value? It can't equal 0. It has to be in this condition. So what would be our smallest value? Is it 1? It's actually not 1. What it would be is infinitely big, approaching 0, which means that you can have 1/2. It's not quite 0, but it's still a value larger than 0, which meets the condition. You can have 0.0001. It's not 0, but it's very, very small and still meets this condition. X can equal 0.0 and going on and on and on and on for an infinite amount of spaces and then have a 1 there. The value can get infinitely big after the decimal point as long as it doesn't equal 0. Hey, thanks for watching this Crash Course video. To watch the previous video in this series, click here. To watch the next video in this series, click there. If you want to request a video, make sure you put it in the comments below. And don't forget to subscribe and like this video.